Good morning, my dear students. Welcome back to chemistry class. I hope we have successfully completed the preparations of alcohols along with some objective questions and also commercially important alcohols, one methanol and one more is nothing but what beta? Ethanol. Okay, beta. Right, now in this class I am going to discuss about the important conversions on the basis of previous topic preparations of alcohol. And also I am going to discuss about the physical properties of alcohols. ये दो टॉपिक के बारे में डिस्कस करेंगे बेटा. Right. Important conversions on the basis of preparations only. Right. How acetylene is converted into ethyl alcohol. Right. Let us go for acetylene. What is the formula of acetylene? C2H2, or we can say that CH triple bond CH. So this is the compound name. What is the compound name beta? Acetylene. Acetylene changes into alcohol means definitely we required OH. OH will be come from only addition of water molecule. Okay, so we are going to do hydration. What is mean by hydration? Addition of water molecule. Hydration takes place, you know very well. What is the required reagent for the addition of water? Dilute sulfuric acid. So in presence of dilute sulfuric acid, and also we can say that in presence of mercuric sulfate, addition of water will be takes place. Hydration step. So in that hydration, you suppose H is given to the first carbon and CH becomes what beta? CH2. Automatically triple bond becomes double bond, and from water molecule OH is given to the second carbon. So we can say that CH connected to OH nano. Okay, na? Right. So double bond is nothing but ene connected to OH. This is nothing but ol. So we can say unstable compound, intermediate compound. This is nothing but what beta? Enol. Now that unstable we have to be make it into stable. On the process is nothing but rearrangement. In previous class also already I told you. So this is called rearrangement process, or we can say keto-enol tautomerism process, nana. So how to do the rearrangement? Here O is connected to H. This bond going to be shift here and pi bond goes to be delocalized towards the CH2. CH2 carries a negative charge, negative will attract positive. So H plus going to be shift over the CH2 and CH2 becomes CH3. And automatically double bond becomes what beta? Single bond. Remaining C, H, double bond O. And also we can say that CHO this is your product. The product name is nothing but what beta? Acetaldehyde. But they are not asking how acetylene is converted into acetaldehyde. They are asking how acetylene is converted into ethyl alcohol. And you know very well. So this is nothing but aldehyde. Aldehydes on reduction gives primary alcohol. That is your ethyl alcohol. Okay. So this is acetaldehyde. Acetaldehyde in presence of lithium, aluminum hydride. So in presence of LiAlH4, addition of hydrogen will be takes place. One hydrogen given to CH beta, CH becomes CH2, and one more hydrogen is given to O, and O become what beta? OH2. So the product is CH3 bonded to CH2 and hydrogen given to O, and O become what nana? OH. This is your product ethyl alcohol. So how to write the statement? Acetylene on hydration gives acetaldehyde. Acetaldehyde on reduction gives ethyl alcohol. Right. Let us go for second one. How benzyl chloride is converted into benzyl alcohol. Right. Let us go for structure. What is the formula of benzyl chloride? Yes, here I am going to take first of all benzene group. Benzene bonded to CH2, this is called benzyl carbon. Benzyl carbon connected to what beta? Cl. So we have to be say that compound name is called benzyl chloride. Benzyl chloride on reaction with aqueous alkali, first method of preparation, nana. And also we can say on reaction with aqueous KOH, and also we can take aqueous NaOH, and also we can add nitrous silver oxide means AgOH we add कर सकते हैं. Right. Now K combines with Cl removed in the form of KCl. Position of Cl minus replaced by OH minus, nucleophilic substitution reaction. Right. Again same thing, we are going to get the benzene group. Yes, here CH2 group is as it is beta. Means benzyl carbon as it is. Now that benzyl carbon, chlorine replaced by what nana? OH group. So here we are getting the product is nothing but benzyl alcohol. So benzyl chloride on reaction with aqueous alkali or nitrous silver oxide gives benzyl alcohol. Right. Let us go for third conversion, Nana. How propane is converted into N-propyl alcohol. Alkene to alcohol. Simply we have to do hydration. Simply we have to do hydration. But if we follow simple hydration, we will get 2 alcohol. But here N-propyl alcohol means it is a 1 alcohol, means OH group should be attacks on first carbon only. OH group should be attacks upon first carbon. So here we can follow the rule is nothing but hydroboration oxidation reaction. Yes or no beta? Right. Otherwise we can go for another short method also. Yes, so propene, what is the formula of propene? CH3 bond CH, double bond CH2. Compound name is nothing but propene. Propene upon addition of HBr. H given to first carbon, Br given to second carbon. Next, Br replaced by OH means you are getting 2 alcohol, but you required 1 alcohol. So we should not do Markovnikov rule. We have to do anti-Markovnikov rule. Means addition of HBr takes place in presence of what beta? Peroxide. Now it becomes anti-Markovnikov rule. Br will be given to first carbon and H will be given to second carbon. Right. CH3 bond CH2 after addition of hydrogen. Double bond become single bond and CH2 attacked by Br. Means here we are getting the intermediate 1 bromopropane. 1 bromopropane. Now we have to do same thing on reaction with aqueous KOH or Machara silver oxide. Let us go for Machara silver oxide, that is nothing but AgOH. If you want you can take KOH also. Ag combines with Br and removed in the form of what beta? AgBr. So position of Br minus replaced by OH minus. So the product is nothing but CH3 bonded to CH2, again bonded to CH2, Br minus replaced by what Nana? OH minus. So what is the position of OH group? 1. So this is N-propyl, straight chain. So N-propyl alcohol, or we can say that 1-propanol. So how to give this statement? Propane on reaction with HBr in presence of peroxide gives 1 bromopropane, which upon alkaline hydrolysis gives 1 propanol, or we can say N-propyl alcohol. These 3 are very important conversations for theory cum objective beta. Right. Let us go for physical properties of alcohols. What beta? Physical properties of alcohols. Right. In that first property, character. What is the character of alcohols? Whether they are in acidic nature or basic nature or neutral in nature. Little bit acidic nature will be there, that is depends on reagent like sodium, Nana. Right. But mostly we have to be say that alcohols are neutral in nature. Alcohols are neutral in nature, and you know very well, due to their neutral nature, they won't react with litmus paper, means blue to red, red to blue. Like these conversions we can't see here because of they are in neutral nature. Due to their neutral nature, they does not affect on what beta? Is no effect on litmus paper, means blue to red and red to blue. Like that conversions we can't see because of they are in neutral nature. Let us go for second one, Nana. This is nothing but physical state. What about the alcohol physical states? Right. So here first of all I want to say about the higher alcohols. Higher alcohols which are having more than 12 carbons. More than 12 carbons. All they are colorless alcohols, all they are odorless alcohols, no smell beta, and all they are waxy solids. So colorless and odorless and waxy solids, little bit oily nature, Nana. So that physical property will be exist only for higher alcohols. Let us go for lower alcohols. Which alcohol beta? Lower alcohols. Lower alcohols, they are colorless liquids. I told you previously very well, methyl alcohol, ethyl alcohol, they are colorless liquids, beta. And so lower alcohol, okay sir, but up to where? Up to 12 carbons. More than 12 carbon, higher alcohol, colorless and odorless. And up to 12 carbon means dodecanol, up to there, Nana. Anyway, so they are what, Nana? Colorless liquids, and they are having a characteristic smell. Yes, they are having a particular respective specific colors will be exhibited by the lower alcohols. Let us see for suppose methanol, poisonous and odor, I mean poisonous smell. And go for one more is nothing but I want to say that ethyl alcohol. Ethyl alcohol, yes, it is a sweet smell colorless liquid, or we can say it contain the odor. The odor is nothing but pleasant odor. Pleasant means sweet, attracted smell, Nana. And oh, we can say this is nothing but alcoholic smell. Yes, and also definitely ethanol. Yes, it is a colorless liquid, you know very well. And ethanol contain characteristic smell, sweet smell, or we can say pleasant odor, or we can say alcoholic smell. And lower alcohols, they contain a special feature. This is nothing but they are available in burning state. Means upon combustion, they will be gives more amount of heat energy. The meaning is they can be used as fuels because of they are available in burning state. Let us go for ethyl alcohol. Upon burning gives carbon dioxide and water molecule, and also heat energy will be released. Due to that reason, we have to be say that ethanol can be used as fuels in uses already I told you power alcohol. Yes sir, no beta? Right. Okay, yes, ethanol is colorless liquid. Ethanol contain the characteristic smell and pleasant smell, and ethanol also it going to be set in burning condition. Oh, and also I want to say that ethanol upon burning, it gives the flame. The flame is nothing but blue flame. Try to remember, very, very, very important. Right. Next I want to go for another topic, boiling points. It was very, very, very important. Next property, solubility. It was very important. These two topics are very important, beta. Right. Let us go for boiling points. Okay. So first of all, here I am going to consider a list of organic substances. Alcohol, hydrocarbon means alkane, alkene, alkyne, ether, aldehydes, ketones. Here I have taken some list of organic compounds now. So I am asking you the questions, and you suppose all they are having nearby same molecular masses, means their molecular masses are nearly similar or nearly comparable. If their molecular masses are comparable, generally we will say that yes, they are having same molecular masses, means molecular weight is directly proportional to boiling point. So we will expect all they are having same boiling point because of they are having nearly comparable molecular masses. But here some gap is there. The gap is even though their molecular masses are same, but alcohols they are having always very, very high boiling point as compared to the hydrocarbon, as compared to the ether, as compared to the aldehyde, as compared to the ketones. The reason is even though their molecular masses are same, alcohol contains more boiling point. Due to reason is why? Because of alcohol it shows two special characters. One is it forms intermolecular hydrogen bonding. Intermolecular hydrogen bonding. I will show you the structures. And alcohols they are having a special type of force, that is nothing but dipole attractive forces. These two reasons, these two attractive forces, they are responsible to say that alcohols are having higher boiling points as compared to the hydrocarbons, ethers, aldehydes and ketones, even though their molecular masses may be same. But alcohol only contain higher boiling point due to presence of these two special inter-attractive forces. Okay, beta? Right. Yeah. So hydrocarbons and ethers, they does not form the hydrogen bond. And aldehydes and ketones, they are also almost does not form the hydrogen bond. But aldehydes and ketones, little bit they are having dipole attractive forces. Okay, but they are also, so just we have to be say that due to lack of hydrogen bonding, these compounds having less boiling point and alcohols are having higher boiling points. Right. So alcohols are having higher boiling points as compared to the other given substances because of reason number one, intermolecular hydrogen bonding. And number two, dipole attractions. Reason they give. Alcohol ROH. H bonded to O, O bonded to R. H bonded to O, O bonded to R. So these are the structures of alcohols I have taken here. And you know very well, as compared to hydrogen, oxygen contains more electronegativity, so somewhat withdrawing tendency. It contains charge partial negative, hydrogen charge partial positive, hydrogen partial positive, oxygen partial negative. In all cases, we have to be write as it is. Right. So you know very well what is meant by hydrogen bond. Electrostatic force between a positive hydrogen and negative oxygen or electronegative species. So between a partially positive hydrogen and partially negative electronegative oxygen, there will be electrostatic force. This is hydrogen bond and denoted by the symbol is nothing but dotted lines. Right. So this is nothing but what, beta? So these are nothing but the formation of hydrogen bond between two alcohol. So we have to be say that intermolecular hydrogen bond, due to formation of that intermolecular hydrogen bond, to break that bond you require more energy. That means more temperature or more boiling point. Right now. S plus minus polar, dipole dipole, दो के बीच में भी attractive force. So we can say this is nothing but again dipole attractions or interactive forces. Okay beta, right. Next one is nothing but I want to go for one more very important point in case of boiling point only. Yes, okay, now in previous class also so many times we have discussed it in first year also beta, right. Generally boiling point is directly proportional to molecular mass and molecular weight, and also directly proportional to surface area, and also directly proportional to straight chain, and also directly proportional to van der Waals forces. सबका meaning एक ही, as the number of carbons and hydrogen goes to be increase, molecular mass is so surface area and straight chain nature and van der Waals forces also going to be increase. So due to increase of this all 3, 4, 5 factors, we have to be say that boiling point goes to be increases. So based on this example, based on this topic, let us go for example. One is methyl alcohol, next ethyl alcohol, next propyl alcohol. You know the structures very well. Once again see the structures. CH3OH, CH3CH2OH, CH3CH2, CH2OH, methanol, ethanol, propanol, butanol, pentanol. Like that we can take number of examples. But commonly in that all examples, number of carbons goes to be increase, molecular masses increase, surface area increase, state chain nature bhi बढ़ गया, and van der Waals forces also goes to be increase. So here all goes to be increase. That means boiling point also increase. So which contain more boiling point, methanol or propanol? Propanol. Propanol or hexanol? Hexanol. Because of as the state chain goes to be increased, van der Waals forces, molecular mass, surface area, everything will be goes to be increased. That means their respective compounds boiling point also increases. I hope you understand. Okay beta? Right. So on the basis of boiling point concept, I want to ask you one question beta. Are you ready? Yes. The question is, I am going to give you mainly maybe 3 compounds. That is nothing but one is CH3, just I am going to give you the compounds only. One is N-butyl alcohol, one more is isobutyl alcohol, you know the structures very well, and one more is tertiary butyl alcohol. Tertiary butyl alcohol, like that, Nana. So they are asking, arrange the following compounds, arrange the given compounds in their increasing order of boiling point. This is the question mark, Nana. Okay, right. So come on, in the 3, one is purely primary alcohol, and one more is purely secondary alcohol, and one more is what beta? Tertiary alcohols. But all they contain commonly butyl group. What beta? Butyl group. So I want to say that one condition, generally boiling point is inversely proportional to branching. Generally boiling point is inversely proportional to what beta? Branching. Yes or no? You know very well. Yes. So when we have to apply this condition we have to be applied only for isomeric alcohols. Only for isomeric alcohols means they should contain same alkyl group. They should contain same alkyl group. So in case of same alkyl group alcohols, in case of isomeric alcohols, we have to follow this rule. Boiling point is inversely proportional to branching. Right. N-butyl straight chain, isobutyl one side chain, tertiary butyl another side chain. As the number of side chain goes to be increases, means here branching goes to increased. As the branching nature increases, automatically respective boiling point goes to be decreases. So for this question answer is boiling point. Yes, N-butyl alcohol contain more, after that what? Isobutyl alcohol, and after that is nothing but what beta? Tertiary butyl alcohol. Because of tertiary butyl alcohol, it is nothing but more branching. More branching means it contain less boiling point, and N-butyl alcohol, it contain no more branches, it is a straight chain, no branching, less branching, more boiling point. So it contain what beta? More boiling point, and last one contain what? Is more branching means less boiling point. So what is the order of boiling points of alcohol? Primary greater than, secondary greater than, tertiary. secondary greater than tertiary. Okay, because of primary alcohols they are having less branching, more capable of hydrogen bonding, and they can ask this question also. What is the order of hydrogen bond formation of alcohol? So primary alcohol and secondary alcohol and what beta? Tertiary alcohol. So this is the order of hydrogen bond formation, and same order for boiling point of the respective alcohols. These conditions are applicable only in case of isomeric alcohols. I hope you understand about the boiling point. Once again, yes, in butyl alcohol, no branching. No branching means more boiling point. Tertiary butyl alcohol, more branches. More branches means less boiling point. So as the branching nature goes to be increases, boiling point goes to be decreases. What is the order of boiling points beta? Primary greater than, secondary greater than, tertiary alcohols. What is the order of hydrogen bond formation of alcohols? Primary greater than, secondary greater than, tertiary alcohols. So this is the information about what boiling points of alcohols. Let us go for one more topic, that is nothing but solubility of alcohols. Solubility of alcohols. Right. So first of all, tell me one thing. Alcohols are whether less soluble or more soluble. So that is nothing but next property, solubility. Okay, solubility of alcohols. Yes. We know very well. Solubility. Alcohols are highly soluble in water. Alcohols are highly soluble in water because of same thing, between alcohol and between water is there will be the formation of what beta? Dotted line. The meaning is nothing but intermolecular hydrogen bond. Intermolecular hydrogen bond. Due to formation of intermolecular hydrogen bond between water and lower alcohols are completely soluble in water. The reason is only due to formation of intermolecular hydrogen bonding. Alcohol HOR, water molecule HOH. Okay, is oxygen partial negative, hydrogen partial positive. Hydrogen carries partial positive, oxygen carries partial negative. Again denoted by the symbol is nothing but dotted line. So between alcohol and between water, the formation of what will be takes place? Intermolecular hydrogen bonding. Due to that reason, alcohols, especially lower alcohols, they are going to be completely soluble in water. And higher alcohols, they are soluble in non-polar solvents like organic solvents beta. Right. And one more point I want to say. Yes, that is nothing but very important. It is also is the question is solubility is inversely proportional to size of alkyl group. Solubility is inversely proportional to size of alkyl group, and also we can say that solubility is inversely proportional to length of carbon chain. As the length of carbon chain goes to be increases, as the size of alkyl group goes to be increases, but solubility goes to decreases. Yes, size of alkyl and length अगर दो भी बड़ा समझो, ऑटोमेटिकली उस अल्कोहल का solubility क्या हो सकता? डिक्रीज हो जाएगा. Yes, I want to say one example. One is nothing but N-pentyl alcohol. One more is nothing but N-hexyl alcohol. One more is nothing but N-octyl alcohol. Okay, yes, pentanol, hexanol, octanol. Yeah, 5 carbon, 6 carbon, 8 carbon, whatever that may be, Nana. So here number of carbon goes to be increase. That means alkyl side chain increase. That means length of carbon chain increase. As the length of carbon chain increases, automatically yes, their solubility goes to be decreases. So which contain more solubility? N-pentyl alcohol, because of okay, the small size or less length of carbon chain is like this. You have to be decided, Nana. Okay, so length of carbon chain should be very small, then that contain more solubility. If length of carbon chain is more or side chain is more, then we have to say that solubility goes to be decreases. Right. So here again I want to ask you one question. Generally boiling point is directly proportional to surface area, but very important beta, solubility is inversely proportional to surface area. What about surface area and boiling point? Directly proportional. What about surface area and solubility? Inversely proportional. Because of surface area means contact area. If contact area goes to be increased, to dissolve that required time is more. If surface area is very small, that going to be easily soluble in water. So that's why this reason we have to be considered. As the surface area or contact area goes to be decreased, its solubility goes to be, if surface area goes to be increased, its solubility goes to be decreased. The relation is nothing but inversely proportional. Again same question, one is N-butyl alcohol, one more is nothing but isobutyl alcohol, and one more is nothing but beta tertiary butyl alcohol. Tertiary butyl alcohol. Right, Nana. Now tell me, in the three, which contain more solubility, first one or last one? N-butyl alcohol, more surface area. Iso, side chain, less surface area. Tertiary, again less, okay, na surface area. So it contain more surface area, more contact area, less soluble. It contain less contact area, more soluble. So this is the order of what, beta? Solubility. Okay, now, so when we have to apply this condition, again same thing, this condition was applicable only for isomeric alcohols, means if their alkyl group is same, butyl, butyl, butyl. In that case, यहाँ पर more contact area, less soluble, tertiary less contact area, more soluble. Okay, right, this is the order of solubility. So tertiary butyl alcohol is more soluble in the 3 because of it contain less surface area and its solubility is very high. Okay, right, Nana. Yes, next topic I want to discuss another topic, another physical property. This is nothing but what, beta? Density. What, Nana? Density. Remember karna padega. Yes, one thing I want to say that alcohols are lighter than water. Alcohols are lighter than water. Water से भी lightweight जैसे consider करना पड़ेगा. Because of water formula is H2O. Alcohol group is OH. OH कितना weight नाना? 17 ग्राम. And water का कितना weight हो सकता? 18 ग्राम. Okay, so यहाँ पर alcohols are lighter than what, Nana? What? Water, because of density is directly proportional to molecular weight and inversely proportional to volume. So with respect to a specific volume, we have to be say that alcohols are lighter than water because of density is directly proportional to molecular mass, Nana. Right. Last and final topic, that is about the dipole moment. Which topic, beta? Dipole moment. What is the symbol of dipole moment? U. It is a topic only for objective, Nana. Yes, we have to be discussed. We have to be remember 3 compounds of dipole moments. One is methyl alcohol, CH3 bonded to OH. It contains 2 lone pair. One more is nothing but ethyl alcohol. That is nothing but C2H5OH. Again, it also contains 2 lone pair. And one more is nothing but benzene. Yes, it also contains 2 lone pair, like that, Nana. Yeah. As compared to carbon, oxygen contain more electronegativity. The symbols are like that. And as compared to hydrogen, oxygen contain more electronegativity. Dipole moment symbol crossed arrow mark. Again यहाँ पर भी same thing, crossed arrow mark. Again यहाँ पर भी same thing. In all cases we have to be show like this only. Like that. Okay, na? Right. So you see this molecule here. In these molecules, COH, it is the dipole bond. HO, it is also dipole bond, and the oxygen to lone pair, it also dipole. You see, Nana, in all the examples, dipole bonds, directions, they are lying in same plane. They are lying in same plane. See this, same plane, same plane, same plane, same plane. Means alcohols definitely, due to their polar nature of CO and OH bonds, polar CO bond, polar HO bond, and polar lone pair nature also, due to this all natures, and they are lying in same direction, means they are having certain net dipole moments. Is in case of methanol 1.71 dB units, in case of ethanol 1.69 dB units, due to presence of bulky methyl group, Nana. And is one more is nothing but phenol, in case of phenol 1.54 dB units. So as compared to alcohol, in phenol dipole moment goes to be decreases, due to reason is nothing but electron withdrawing nature of phenyl group, and also that lone pair undergo delocalization in making resonance structures with benzene. Due to that reason also we have to be say that little bit dipole moment goes to be decreased. And also here, okay, but in case of methyl alcohol and ethyl alcohol, here, okay, no more resonance because of absence of pi bond. So they are having certain somewhat little bit what? More dipole moment as compared to the phenol. Okay, beta? Right. Physical properties are over. In next class we are going to be discussing about the chemical properties. Right.